Okay, so into the first question what we have taken the question where it's mentioned that two circles are given to you which are in contact with each other. This is first circle, and let's say this is the second circle, right? This is given to you and it has some common tangents. Okay, so what will be the common tangents to this circle? Okay, let me draw it. Definitely the common tangent, that means this is the point of contact, you can see, and here the common tangent is passing like this, right? And another tangent which is just crossing is just drawn like this, because tangent will be touching the circle at single point and it just crosses, so it's basically like this, right? So here you can see this is the point of contact, right? Under the question is given that two circles touch each other at a point C. So C is the point of contact over here, right? This is the point C, and we need to prove that the common tangent to the circles at C bisect the common tangent at P and Q. So for the bigger circle whose center is let's say A, so the tangent is drawn at 2 points for the bigger circle at P and C. Similarly, for this smaller circle having the center at B, it is having tangent at Q and C, right? Tangent is a, what is a tangent? Tangent is a straight line which is just touching a circle, okay, and crossing through it. And when you draw a radius from the center towards the tangent, it is always making an angle of 90 degrees, right? So this is the property of tangent. So into this question, we are given, this is a question from CBSE in one of the previous examinations this came, okay. So it's given that the two circles touch each other at C point. We need to prove that the common tangent to the circles at C bisects the common tangent PQ at P and Q. That means, let us say this tangent which is just, you can see the common tangents to both the circles. One is CR and another is PQ, right? So two common tangents are here given to you. Now we need to prove that CR bisects PQ. CR bisects PQ. This need to prove, right? So if CR bisects PQ, that means PR will be equal to QR. That means PR is equal to QR. That we need to prove, right? So to solve this question, let us understand what is the property of a tangent and how the things will happen over here, okay? Since this is the tangent, CR is the tangent common to the circle, both the circles, and R will be acting as an external point. So from an external point, you can see tangents drawn towards P here and towards C also. So the from R as an external point, you know the property of the tangent, from any external point, when tangents are drawn to a circle, then the distance of both the tangents will be equal. So from this property we can say that PR equal to CR, isn't it? From an external point, R is the external point, from here two tangents are drawn, that is RP and RC, and the length of both will be equal, right? Tangents from external point R. That's why RP equal to RC. Similarly, from R, you can see two tangents are drawn to the green circle here. So that's why again we can say RC equal to RQ, right? So from, since this is the one of the relation, RP equal to RC, and Using the same relation for the smaller circle, you can see R will be acting as an external point, and from this point RC and RQ, length of RC and RQ will be equal because both RC and RQ are tangents to the circle, a smaller circle. So that's why we can write RQ is equal to RC. So this is another relation which can be written, right? Now using both the relations, what we can write from this equation and this equation, we can write that Rp is equal to Rc is equal to Rq, isn't it? All these three are equal to each other, right? Since all these three tangents are equal to each other, then we can say that Rp equal to Rq. From here you can see Rp equal to Rq, right? So we are writing, since Rp equal to Rq, that means Rp is equal to Rq, then we can write that PQ as a sum of Rp and Rq, right? And Rp is equal to Rq, this one. Therefore, we can write PQ, therefore we can write PQ is equal to Rp plus Rp, Rp plus Rp, because Rq is also equal to Rp. Rq is equal to Rp, so we replaced Rq with Rp, right? So with this, we can say that the length of the tangent PQ is equal to 2 times Rp, right? And we can say that PQ by 2 is equal to Rp. So if this is proved, right, then we can say that R is bisecting PQ equally. So we are able to prove that the tangent through C, that means the tangent through C which is intersecting the PQ tangent at R is bisecting it, right? Therefore we can say that PR equal to QR, or it bisects it equally. So this is proved, students. So in this way we have proved that the tangent CR, this one, the tangent, so for both these circles there are two tangents, two. So we have proved that the tangent which is crossing through C and intersecting the another tangent PQ at R is bisecting the tangent. Okay, so we can say that CR bisects the tangent PQ, right? So in this way, students, we have solved this question. Thank you so much for watching. Be connected. Happy learning. Bye bye.